Hey everybody, I hope you can hear me just fine. This is the first live that I've done on my phone. So just hold on a second. I'm getting set up. Just waiting for people to mosey on in. I'm not sure how this live thing works. Let's see. Come on. Da, da, da. Everybody come on in. Have a seat because we're going to run the Stubby Fan on the new Avian. We're going to do it until the battery is pretty much depleted. And it's going to be one of the dim situations where... Okay, it looks like we're up. Cool. I will try to answer questions as you ask them, but okay. So, welcome all. This is Stubby Fan version 1, which I am now running on a new Avian 100 amp ESC. It's a smart ESC EC5 connector that I just found it yesterday because I'm dumb. And this thing has a 120 amp burst. It it has telemetry. It's for smart technology from Spectrum. It's really cool, but it outperformed another analog. I want to say this is just analog, but it's probably partially digital. I have no idea. I should probably read up on the product specifications. But the point is, this one is the I'm Totally Blind SPMX-AE 1100 Smart ESC from Avian, from Spectrum. It's a really good ESC because it has given this motor just a ton more power. So what we're going to do today with this battery, it's just a 50C discharge rate. It's an HBR. It's 5,000 milliamps, 22.2 volts. And it's going to run roughly at half throttle for as long as humanly possible. Don't worry, we'll do some walk-arounds. We'll, have video that's stationary, so on and so forth. We will be taking temperature readings of the motor as it's working. So let's get it hooked up. Now the reason I am doing stuff like this, hey David, welcome to it. Hope you enjoy what you're about to witness. James Fraser, thanks for coming in. I'm gonna get everything. Hold on, can I ask a rather annoying question from ASA Arrow? Preset, yeah, ask away. I mean, it's just if there's a delay, let me know. And I apologize if there is a delay, but yeah, ask me for sure. Oh, there's a lot of people. Okay, this is my first online live on a phone, so if I don't see you right away, I apologize ahead of time. So we're gonna get things hooked up. Go ahead and shoot your question over, and I will try to answer it to the best of my ability about the ASA Arrow. And now what we're going to do is hook this up. It makes the coolest sound when it hooks up too. It's way better than a standard ESC. And people are like, man, this guy's been in the dark ages for a while. Because they probably had it for a long time. Okay, so the radio's on. Everything's working. Love it. Fans going. It's just a really good ESC. So I'm going to pull this battery back a little bit. That way we can kind of easily monitor temps. We will monitor temperatures of the heat sink on the ESC. And we're going to monitor the back of the motor where the wires go in up towards the front. And I'll give you temperature readings. I'll have to get closer to the camera because there'll be some clipping because it is an iPhone of the sound. So that's how we're going to do it. I'll try and read them off to you later on if I if we don't, if you're not able to hear me. So let's get started with a baseline temperature 75 degrees. ESC is 75. Battery 74.8. Okay, so the engine, everything's within 75 degrees. So we're going to ramp it up really quick, and we're going to get everything turned so you can kind of watch and listen and enjoy. And then we'll do some walk-arounds. I don't know how orientation changes work, but we'll go from there. Which one of the live downloaded presets? Oh, yeah. You know what? When I did I'm sorry, James. When I did the bundle, there's a bunch of presets for different PLAs. I didn't know it was going to grab all my PLAs or all of my settings and put them out there. I thought it was just going to do the arrow. So just use the arrow. And I have discovered if you're going to use supports to run it with, walk the speed down on the normal printing speed to 500, like keep everything at 500. And the printing speed itself around 40 for the supports, and just go from there. We'll discuss it more, and I'll get it to you. What I'll do is I'll post it up on a post what I'm running now for some solid prints. So, all right. Without further ado, we will go to half throttle, and we will hold it and check temp periodically, and we're going to see how long this 5,000 milliamp runs it. This is an 800 kilovolt motor that is, it's basically a propeller motor. Runs off of anywhere between an 80 to 100 amp ESC. It can overload if I push it too hard with this ESC, so I'm not going to. So that's what it is. It's just a regular propeller motor. And then, of course, the EDF fan design. And we are going to start now. Hey Chad, how's it going? I am absolutely getting blasted back here. don't know if you can hear me talk over it. This is a throttle setting I like to use when I'm wanting to cool the system down. So it would be like at a cruise mode, not a cruise mode, but more likely a kind of coasting phase as you're coming down from altitude. If you need to, because I plan on putting this in a large wing, and then I even using like old RC truck wheels on a chassis to hold the battery and for landing gear, like the most hillbilly B-52 you'd ever seen in single engine. But it's going to be fun. And that's why I'm running this endurance test, to make sure everything runs good, to make sure nothing burns up. This Avian ESC is absolutely amazing. Let's go ahead and push it up to a full throttle run. I don't know how much battery I have left. We'll see. Yeah, it's starting to lose some oomph on the battery, but we have some pretty good run time. And the idea was to run this at a cruising speed, just to see how well it would do on a 5,000 milliamp pack and how long it would last at a good cruising speed. Sounds like it's starting to slow down. Oh yeah, it is. So we're gonna let it come down to a slow idle, just to let it cool down for a little bit. I don't know how long of a runtime that was I should have had a timer going. We'll go by the video though when I go over the live. Yeah, and that's it, and it shuts itself off. Yeah, low voltage. Okay, so this gave me has a low voltage alarm set on it, so that it doesn't destroy the battery because it's a smart ESC. So that's what you're hearing right now. It got to a voltage point where it needed to cut off. Would it have more? No, that's a low voltage alarm. it's done right now. So that was 5,000 milliamps over roughly, I want to say at least 12 minutes, I would think. Let me get it unplugged real quick. I want the ESC to kind of cool itself because it's still running its fan. And then we will shut it off. All right. Does anybody have any questions right now? Because this has been the longest run that I've had so far. I haven't tried the 6,000 milliamp pack because I'm using the Avian. I need to make an adapter from XT90 to IC5. And then I'll be able to run the 6,000 milliamp at 100C. But I think 50C is plenty. Even the 70C 2200 milliamps, I could run those in series. And that would easily disperse them out over the wing and still give me close to, you know, the 5,000 milliamp pack. But ultimately, I may run it just in the middle underneath where the feet are. You can see underneath here, you may or may not be able to. Underneath here, there are feet that were originally designed for carbon fiber rods. and that was to connect to a drone. Because these engines, the reason why there's a cutout here on the back side, I'm going to stop this now. I think it's cool enough. Well, it didn't weld itself together, so that's a good sign. Come on, turn it off. There you go. Okay. So what we have, yeah, it is an accomplishment. Thank you very much. So what we have is with the Avian ESC 100 amp and an 800 kV motor that I got from Turbo. And you could probably get a higher quality motor. This was $40. I was thinking about running one of the Avian motors with it and doing the same thing, building a separate fan. I think another single fan with a higher quality motor with better windings would probably give me a little bit better performance. Plus, I may change the bearings from a greased high-speed bearing to a standard high-speed steel bearing because I think the grease inside the bearings will give it a lot of friction, and that could put some load on the motor. But I haven't decided whether or not I'm gonna do away with that because I kind of like the idea of having high RPM steel bearings, especially in this system. What else? I am gonna get wings for it, and it's gonna be the centralized hub. I'm gonna go into Fusion and design a bonnet and a cloud. Then I'm going to basically get it set up to work and accept carbon fiber rods that go into the wings that I get. So we're looking at about 2.5 to 3 feet on each side, with a large enough airfoil to give me some lift, like the B-52. And that is for the purposes of seeing how much thrust, how much lift we get out of this motor. I'm using the truck chassis because it's a lot of material. You know, just having the truck chassis with the suspension and the tires, at least I can land in the grass. It'll also add more weight to the system, which will prove more what it can do. And that's really what I'm aiming for. So not everyone. Sometimes people want to build things to an efficient end before they construct. I want to build it efficiently, but I want to overbuild it so that I know that when I cut back on what I don't need, there's that much more thrust to weight, there's that much more power, there's that much more duration. That's the process behind different iterations of the fan. So this one is for a drone. That's why it has a cutout so that it has some stabilization of outflow in this direction. The other ductwork for the other fan will be a little bit longer and come down to a smaller aperture at the end. And that will, it also has a different mounting design where it has two arms. It looks like Shrek. It has two mounting arms coming out for carbon fiber rods and one in the center. And that's so that it can hang from opposite wings. And then I'm going to run it, of course, with the Avian and an Avian motor. I'm wondering if an Avian motor and a smart battery all together would be really cool. They're just super expensive. So I had to get the Avian ESC first. Then I'll get a smart battery that has some high milliamp ratings. And then I'll get an Avian motor. The Avian motor I'm going to purchase next, but I haven't really decided. One of the Avians I'm going to get is a 450, and that's for the twins. And then and I'm designing a new frame system around for that before I do any duct work, because I want to make sure all the internals are the way I need them. And then I'll run the 450 Avian on that, and then I'll get another Avian around 800. I might even be able to get away with 1,000 to 1,200 kV, depending on the quality of the motor. It's all about how much mass it can turn. This got up to 124 at one point, but it wasn't outside operating temperatures. I mean, I think that's pretty solid. So ESC around 150 at the rear, close to the capacitors, 167 at the max, but the fan was doing its job and it was keeping everything nice and cool. So on the ESC, so it's a great ESC. I think running 2 of these and 2 motors, and then 2 6,000 milliamp packs on a massive wing would be just, you'd have a cruiser. You'd have a high altitude cruiser, and it could carry a payload for sure. So if you're looking to do like FLIR imaging of a large area or LiDAR scans, this could be a potential setup for that. So there are different, there could be military applications for it. They're always looking for ways to not, waste money on fuel. So electric could be the way to go. And this is a decent electric turbine, especially for someone creating it out of the garage and basically having ADHD. This is like, no, we don't need this part. Are you sure? Probably. Let's try it. It worked. Okay. So, that kind of thing. So this was a good test. This was a good test of battery longevity and heat in a static environment. It was able to manage the heat really well in a static environment. And in a dynamic environment where higher up in altitude and it gets cooler, you end up getting cooler air, which means better results in cooling. You get lift, which takes load off the motor. So this situation, I had to put the toolbox there and turn the wheels just because it would push the table off the carpet. So, yeah, I think this is a really good pairing, what I have going on here. This fan around an 800 kV motor. But if it's a higher quality motor, I don't think it'll get as warm. I'm not saying that Turbo doesn't make quality motors. I'm just saying that it was $40. Okay, and the Avian is $140. So I really want to see the difference. I want to see if there is a performance difference. This may outdo the Avian, even though the Avian's $100 more. So we're going to find out as soon as I get the Avian. So I kind of hope that this has been informative. I know that there was a question on ASA settings. If you're still here, James, feel free to ask away, and we'll answer some questions. This live is weird. I don't know how to flip the camera. Oh, wait, yeah, I do. Hold on. Let's get, look, it's the twins. All right. You can see what the turbine did to my hair. So, what questions did you have regarding ASA? Because I will do my best to answer them. If you're still here. If you're not, it's okay. You can ask me in an email. You can do whatever you need to basically get your question across, so I can make sure that I get it answered. Because I did make some changes to the original setups or the presets for the ASA, because it was printing okay. It just got to the supports and it would just real quick, and then it wouldn't do it. It wouldn't work. So I made some tweaks. I went into the normal printing area and I took it down from 10,000 to the same as everything else, which was 500. And it slowed the print down, but at least you got something out of the ASA Aero. It's just, it's finicky. So you have to be really careful with it. Yeah, and Chad, the long range concept is where it's at. That's the idea. Is you want to make sure that you can not only design a system that's going to be good at dissipating its own heat, but under a cruise mode kind of situation where you're running at around half throttle. And this is all going to be dependent on the lift of the wings and the design of the aircraft. You're going to end up wanting to know how long a battery pack is going to last, to the point where you can put it in a loiter mode if you decide to use a SpeeDB setup. I think even with the smart technology, Spectrum has setups where you can do a loiter mode. I'm not sure because it's been so long since I had a Spectrum. I have a TX16S, and I don't know all of that yet. I'm still working on it. I'm still working on learning all the ins and outs of that one. But the idea is to create a turbine and then that's dependable, that works good, maintains good temperature, and can provide consistent lift, consistent thrust. And I think I've done that. And as long as we have the battery power, I think something with this size, I think we could put a couple of them in a wing that size and run for twice as long as I just did. So, and with it not being in a static environment, the next test will be a dynamic environment where I'm flying, where I'm not always at half throttle, where I'm not always using, I'll be using the lift to do some flying. I'll be using ailerons. I'll power into turns or power into loops, that kind of thing. I don't know if I'll get that crazy yet, but keeping it at a half throttle and then running it up a few times like I did kind of showed the capabilities of it. And you're talking about an EDF style engine that ran for a lot longer than a standard EDF did. That's for sure. And it produced a significant amount of thrust. You know that because it can move this entire table easily on a carpet. So, and it's in their rusted wheels. And I don't think that fish scale ever gave me a good a good thrust to weight ratio. Just because I think it's a fish scale. I need something a little bit more professional. I need a little bit more like a load sensor for an Arduino and then set something up. But ultimately, instead of spending all that money on those parts, it's buy wings, find the bottom of a truck with wheels and suspension and put the battery in it, mount the motor to it, get the wings, and set up everything and put on the ailerons, and it's going to be an Elevon system because it's a wing, and go from there and see how she does. So that'll be what we do next. And I may print a new fan to do that, just so I don't lose Stubby V1, because it's sort of like, it's like that trophy you put up there when you don't want to use it, because you don't want to break it, because it works. So I think what I'm going to do is because I already have the design, I'm just going to print another fan. I'm also going to print it at a different infill on some of the parts to lower the mass. We know that the blades need to be, almost full infill. There's only a few parts that do need to be solid infill. There are some that print solid infill whether you like it or not, especially even at 2 wall loops. So, let's see. An Enterprise drone? Wow. Yeah, I could do that. I mean, I'm sitting here. If I go silent after you give me an idea, it's because I'm already putting it together in my head, and I know what you're thinking about because it looks like the part where the deflector dish is, and I know exactly where your head is at. And tell me I'm wrong. I'd say it ran as the same as a 80 millimeter for about. For time, but 203 millimeter force multiply. Yeah, I'd say so. 5 hours from now, it'll be in CAD. Yeah, I think you're right though. Sucking at games. I don't know what to call you, man. Do I just say sag? I don't want to be mean or anything like that, but I don't want to say you suck at games all the time. But because I suck at games, you can't have that title. You put me on a mouse and keyboard, put me in COD. That's it. I'm cannon fodder. Sag. All right, as long as you don't take offense to it. That's all I ask. But I knew what you were talking about. Like as soon as you said Enterprise, I went, damn, all I need is a shuttle bay at the back side of this thing and some nacelles. And then just run it up to the... Oh, you're giving me ideas, man. You know how many ETFs I could put in just the disc? Just the top part of the ship. And in the nacelles. And then use this to move forward. You guys are killing me, man. I'm like trying to work on one project, and you put another one in my head. That's funny. That's actually funny. But yeah, that's a good idea. I now have to build... Thank you, SAG. Now I have to build an Enterprise. Oh, SAG's the name of your channel. I got you. All right, that works. So I don't feel bad for saying it. You guys will pardon me while I have a little bit of pipe tobacco. But I'm not going to do it, like, on camera. Ugh, if I can reach stuff. Just so you know, it's pipe tobacco. I'm not going to throw it out there on a live because I don't want to, like, promote people. Because nobody has asked me to basically sponsor them. I'm not sponsored by anybody who is of the hardware that I'm using. I'm not sponsored by anybody at all. I'm sponsored by you guys. You guys are the ones that sponsor me. You guys are the ones that make it possible for me to continue to be inspired. Because now I have to build NCC 00. What is it? NCC 1701D? Which one do you want me to build? I mean, I'm serious, SAG. And in the window of 10 forward, you're going to see a big printed middle finger. Because you just gave me a whole new project I have to do. All because I'm looking out now and I'm going, this looks like the Enterprise. This is your fault, man. The reason why I'm lighting it up off camera when it comes to the tobacco is because I'm always afraid that I'm going to do something wrong and YouTube's going to go, no! You know, because sometimes they shadow ban me or do something. I don't know why. You would think that I would have a lot more subscribers because I'm sitting at about 73,000 views on a monthly basis every 28 days when you look at the analytics. It doesn't seem like a lot, but for me it is. Because I'm not used to people watching me do my stuff, you know? And I wanted to share it. I wanted to make sure everybody enjoyed the hobby. So we are going to get to the point where the Stubby Fan's STL files, I may put them up for... I feel like an ass if I say I'm going to sell something. And then somebody tells me, don't feel like that because you put a lot of work into it. You know? It's like, do I sell the fans? Do I build the fans and sell them? Do I sell the STL files? What do I do when it comes to that? I'm reading the chat. I apologize for being silent. I'm reading the chat. You'll have to elaborate. Sag, I don't know what you mean. Because I want to know for sure. I may just be misreading it, mainly because I'm supposed to be wearing glasses with bifocals, but I hate them because I lived most of my life without depth perception. So putting those on, and because I had eye surgery when I was like 5, because my eye was basically rolled back into my head. So it's hard for me to see the chat because unless I'm using the bifocal. But if I use the bifocal, it pulls my vision out to where I'm not monovision anymore. And that's why I was a left-handed rifleman in the military, but I'm right-handed because I'm left-eye dominant. And oh my gosh, the drill sergeants gave me so much crap about that. And when we did Nick at Night, where you're firing tracers like crazy, I was oiling my eyeballs, man. I'm not even kidding, because I didn't have glasses in the military. But for some reason, how do you pass an eye exam when you're monovision and go in and they're like, you're good, you got 20/20? I'm like, yeah, but I'm left eye dominant. They didn't say anything. They didn't care. So, yeah. Anytime I was on the range, it was. I still made sharpshooter, but I was doing it through oily eyeballs. Because every time I would fire downrange at the targets during qualification, I'd get that spray of oils and gases right in the face. And I still managed to hit targets at 300 on iron, on iron sights. And people nowadays, they're like, wow, that's insane. You can't do that. 300 yards, iron sights? I'm like, man, we learned on iron sights. We didn't get the old fancy optics back then. It was a fun time. But anyway, that's why it's hard for me to read. So you see how I ADHD off into a completely different tangent? So that's why I can't see the text, because I have to wear the bifocals. And when I wear the bifocals, it makes everything more three-dimensional to me, which disorients me. So I end up stumbling all over the place and trying to learn how to perceive the world again. So they're like, oh, but you've got to wear them. Yeah, you would think that an electric EDF, because if you think about what I've done here, I've taken what you would consider a turbine engine. It's supposed to be spinning at extremely high speeds. And the implementation of a planetary gear is coming next for the V1. Because I want a 3-to-1. So that's why I haven't really chosen another motor yet to try and push it. Because if I'm doing a 3-to-1, I got to lower the kilovolts. So that's going to be something I test in the future. And I have another project nobody has seen that will be out pretty soon. And that is actually running off of an EDF motor. So the RPMs are going to be insane. So yeah, having an electric turbine engine, and then with the charging technology we have, the battery technology we have, the solar technology we have, the hydrogen technology we have, there is no reason why that this couldn't be applied to the world at a much larger scale. And I'm telling you right now, when I get to that point, you are going to see me on a quad, but it's not going to have wheels. That's what the Shrike drone was part of. That's what the Shrike XL is going to be part of. All testing for an EDF quad that can run at street level and maintain altitude, but you could still go up to 400 feet without any FAA regulations. I'm sort of probably going to try and regulate it after they see me fly to the store. But self-leveling, emergency parachutes, whole 9 yards. Basically, it's going to be a quad that I will fly remotely at first, because my wife's making me fly it remotely at first. Because if I don't, she'll kill me. So, and that's joking, YouTube. I'm not talking about actual taking of life. So, please relax. I know there's a sensor that sat up really quick and spilled his coffee. Let's get ready to press the button. Hovercrafts are a good idea, but the idea behind the quad is that it can take off and land. It'll have gear to land on, obviously, but it'll take off and you can roll at road level, and it will have fail safes. Like the undercarriage will have small, um, small, basically quad wheels, so that you can still steer. So if you happen to lose an engine and you're at street level, you can drop back down on the wheels and slot and basically slow down to a stop. Um, and then the engines they'll tilt up to where they don't get damaged. So the idea is that you can still fly at street level, and and if there's an accident, you can go up and around. I don't over an accident's never something you want to do. So you find a safe way around, and eventually there's going to be, once this is implemented, if it takes off, pardon the pun, then you're going to have a situation where um, you're going to have to start developing infrastructure for this type of conveyance. So this is really what I'm going for. So, and because you have to remember, Stubby Fan's running off of an 800 kV motor designed for a prop. And it's using one 5,000 milliamp battery, ran for as long as you just saw it run at a good cruising speed. And it used minimal power, minimal technology. The rest of it was just mechanical. And it worked out well. And I think that when I do Shrike XL, since it's going to run 4 batteries and 2 Taro power distribution boards, because I have to, because Advanced Power Drives decided to stop selling to the public, so I can't get the boards I like from them anymore. And so I have to go with a different power distribution board. And yeah, that's what's going to happen. We're going to do the Strike XL first, which will be 4 of the engine you just saw run on a drone setup. I'll be using a SpeedyBee F405 wing in order to run it. It'll take power directly from a separate pack. Each engine will have its own battery pack, and it should produce enough power with 4 Avians, the way that they're running, to give me some significant RPMs. That's why I'm going to change the 800 kV motor to a higher quality, possibly get an 11, and see how it does with the Avian. But it has to be a quality motor, because I ran an 11 on a fan and it burnt the motor. The 800 seemed to be great, but I need more torque. I want the RPMs, but I want the torque, and that's why I thought planetary gears. But then instead of going up in the kV range, you have to go down in the kV range in order to make sure that you don't burn up everything. So realistically, the idea is I'm either going to planetary gear this at a lower kV, or I'm going to find a suitable higher kV motor that doesn't burn or overheat with the mass setup that I'll have. And the next fan, like I said, will have less mass on the internal rotating parts and possibly unsealed, ungreased bearings, maybe with gun oil, but I think they'll do just fine because they're pretty much sealed inside the system. They don't get any debris in them. So we're gonna try it with that, and that'll kind of take a lot of the struggle out of how the motor has to operate. Because when you're running in a drone mode, um, when you're running in drone mode, you have to be able to make quick motor responses. So you want to make sure that the mass isn't going to overheat the motor. So we are doing a reprint, and I'm currently right now working on another one, like I said, but we're going to do a reprint with as light as possible as I can print it. Not with an ASA or anything like that, or a PLA Aero, because they're just too flexible, and I don't need that. I might do it for the duct work, an ASA Aero. No, a PLA Aero, because ASA give me nightmares. But the PLA Aero prints really good. I had tons of luck with the PLA Aero. That's what I did the wings of the Jav with. And you can see how they're flexible, right? But they're still, I can't see. Okay, there we go. That's my fault because I glued it a couple times already. But the whole thing is, it's tough. But as an air duct, embarrassing moments on live. Would anyone like part of the Javelin? So that's okay. I'm taking it apart anyway. The idea is if I do the ducting in PLA Aero, then that'll lower a lot of the mass as far as the overall lift weight. If I do the outer casings that I don't need to have, or the inner spool that holds the rear LP low pressure turbine blades, I could do that in PLA Aero because I can still print it solid like it's printing now, and it'll still be strong enough to do what it needs to do. So I'm figuring out which parts I can print with less mass to give it an opportunity for a higher kV motor to spin it. The main blade will always be a solid PLA or PETG because you've got to have a solid front main fan. My hair just gradually gets worse, doesn't it? But yeah, realistically, the idea is I've almost got a perfect match going on here. And even with this heavy mass printed V1 Stubby Fan, it's running great with an 800. So I think I can get a pretty good 1100 on there if I buy not a cheap motor, but a fairly expensive one, something that has good windings. And then print everything like I just discussed with you at the lower masses and using different materials where I can. And I think we'll have struck gold when it comes to the 4 engines I'm going to need to do the Strike XL. Because once the Strike XL goes, once the Strike XL flies, it proves that I can build a larger platform that produces enough thrust to lift weight. And that's when the CNCing comes in. You see how I delivered that completely backwards? I have a friend that's built a shop. He's going to have a CNC and a laser and everything else. So what we're going to do is that's when we start building the turbine for the quad. And he's good at TIG welding. We're going to start buying aluminum. And we're going to start framing stuff up and working on the initial concept for it. So, yeah, I think we're on the right track. So next thing I'm going to do is build a fun little plane for this V1 to fly in. I really hope that you've enjoyed this live. I hope you enjoyed watching this thing spin up and eat that battery. And I hope that you think that it was a really good run and that it proved itself. So, yes, odd channel. That I remember Strike was my favorite. I miss it dearly. But again, APD took away my ability to buy 500 amp power distribution boards because they want me to LLC first. Like, I started to make progress, and they LLC'd me. They're like, oh, you got an LLC or we can't sell you any. And then, of course, you got to buy like 400 of them. But thank you all for being here. I appreciate it. And as soon as I learn how to end this live, that's what I'm going to do. Let's see now. Not that one. Not that one. Not that one. Is it this one? It might be this one. Love y'all.